Okay, welcome back. So just to set up this last example here, I'm just going to make a quick little chart and just sort of see what happens to the amount that I have to pay Scott every day over the course of the 30 days. So for in the first day, if I put everything in dollars, I owe him 1 cent. So that's going to be $0.01. Okay, on the second day, it doubles to 2 cents, so I get 0.02. Then the third day, it's 0.04. So you may notice here it's doubling from day to day, so the fourth day is going to be 0.08, and then it's going to continue on, and so on and so forth. So one thing you might recognize here right away is that this is going to be a geometric series because geometric sequence because we're consistently multiplying by 2. So what this means, if I want to treat this as a sequence, my first term is 0.01, and my r is 2. So to answer part A, where it says how much will I have to pay Scott on day 10, well, on day 10 I'd be looking for the 10th term. So on the third day I pay him 4 cents, or on the fourth day I pay him 8 cents, the fifth day it'll be 16 cents. How much do I have to pay him on day 10? So to find the 10th term, I need to find a general term first. So Tn will be a times r to the n minus 1. So if I put in my a, it's 0.01, my r is 2. So quickly, I very quickly get my general term there. So to find out how much I have to pay him on day 10, I'm going to put in n equals 10. So the 10th term of this sequence is going to be 0.01 times 2 to the 10 minus 1. So that simplifies to 2 to the exponent 9. So if I run that through my calculator, that's going to mean that I owe him $5.12 on the 10th day. Okay. So that's how much I have to pay him on day 10. Now, part B says how much will I have paid him in total after 30 days. So if it's in total, then you know how much I'm going to add up everything I paid on day 1 plus everything I paid on day 2 and everything up to including 30 days. So I'm really trying to add up all of my first 30 terms. So what does this mean? It means it's going to be a geometric series. So I need to use a series formula here. So let's get that series formula up. Let's put in everything I know. So I want the sum of the first 30 days, so my a is still 0.01, my r is still 2, but it's over 30 days. So let's put it in and see what we get. Okay, so you might have an idea just by looking at everything I put in here. This is actually be a very, very large number, which seems a bit counterintuitive because I only start by paying him 1 cent a day, and I know it doubles, but I start with 1 cent and then 2 cents. But you'll see here when you do 2 to the exponent 30, that's a very, very large number. So it's actually 1,073,741,824. So a very, very large amount of money. And subtracting 1 doesn't make that much smaller. And then I multiply that by 0.01 and divide by 1. It still gives me an amount that I've paid him in total of a very, very large number. So I wind up having to pay him in total $10,737,418.23 in total after 30 days, which is a ridiculous amount of money. So it's really a good example of how fast things can grow when you're talking about things growing exponentially, right? So starting off with only 1 cent in one day and then 2 cents a day after that, quickly after just 1 month it becomes over $10 million. Okay, so that's a good application of a geometric series. That's it for this. Please practice the homework and let me know if you have any questions. Okay, that's it.